Hi, in this video, I'm going to talk about the hexadecimal number system. First of all, here's some of my, simple number system rules as far as integer-based number systems. Now, first of all, if you understand our number system, base 10 decimal, you're going to understand any number system. First of all, think all digits start with 0, okay? In whatever base number system we're talking about has base as that number of digits. For example, decimal is base 10, so it has 10 digits, starting with 0. Binary, base 2, has 2 digits, starting with 0. And hexadecimal, which we're talking about here, is base 16 and has 16 digits, starting with 0. All right, the first column, the rightmost column, least significant column, always starts with the number of ones. Okay, we'll see that in a moment. And then each column following that previous to the left is that times the previous column by the base number. Let me show you what I mean here. So here, notice we have in base 10, okay, we have the rightmost column of ones. Now, because we're talking base 10, this column here is 10 times the previous column. The next column, 10 times that column. This column, 10 times that column, etc. It's that simple. Okay. So base 2, as we'll talk about later, is or in another video, is the first column of ones, and every column after that is 2 times the previous column. And in base 16, column of ones, then base 16, 16 times 1 is 16, 16 times 16, 256, etc., etc. But don't worry, we really never have to go past that first column for what we need to do. All right, so let's take a look here. We have, I said base 16 has 16 digits. Let's go through those digits. So in decimal, we have 0. In hexadecimal, that would also be a 0. 1 in decimal is 1 in hex, 2 in decimal, 2 in hex, and we just keep on going. So they use the same digits until we get here. We've run out of digits. In decimal, we have 10 digits, 0 through 9, including 0. But we need more digits for hex. 1, 2, 3, 4, 5, 6 more digits. So we need to use something. And probably the best, and well, definitely the best thing to use is another sequence we can remember. We don't want to use like hashtag, £, exclamation mark. We want to use something we can remember that already has a sequence. So let's use letters. A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. So if we were in the world of hexadecimal and a child turned from was 9 years old and had a birthday, was now 10 in decimal, she would be A in hexadecimal. Next year, she would be B in hexadecimal instead of 11. It's just a different number system. Let's take a look at it like this. So the last digit that we have here in hexadecimal is F. Okay, so that's 15 in decimal. What happens when she turns 16? It's no problem. Remember, the next column is 16 times the previous column, the number of 16s. So it'd be 1 16 and 0 ones. Well, what if when she turns 17? 1 16 and 2 ones. 16 plus 2 is, oh, wait a minute, I blew it there. 16 plus 1. Good catch. You're going, what's with Rick? 16 plus 1. 16 plus 1 equals 17. There we go. All right, what if she turned 18? 1 16 and 2 ones. All right, let me erase this here. Let's try a different one. All right. What would happen if she was, let's go with, let's see, 23. Okay, well, that'd be 1/16. Okay, let me put 23 over here, subtract the 16. And if I can do my math here right, that would leave 7 ones. Okay, how about 25? That would be 1/16 and 9 ones. Can you do 26 for me? Ooh, 26. Let's see, 26. Okay, so that'd be 1/16. Subtract the 16. 10 ones. What's 10 ones? Oh, yeah, A. 1A. 27 would be 1B. Let's do just a couple more of these just to kind of give you an idea. All right. What would be 32? There we go. 2 16s. 16 plus 16 is 32 and 0 ones. Okay. So in these columns, whether it's 16s or ones, we can have anything ranging from 0 to F, or in decimal, that would be 0 to the value of 15. All right, so let's talk a little bit about why we use hexadecimal. The beauty of hexadecimal is that it's perfect for matching 4 bits. Okay, so you'll see this in the binary video if you haven't already seen that about binary. But with the beauty of hexadecimal is that we can represent any 4 bits with 1 hexadecimal digit. Okay, so if you're familiar with binary, if you're not, we will be talking about it in another video. But in binary, we have 4, in this case here, I'm going to show you 4 binary digits, starting with ones. Whoops. Do that again. There we go. Starting with 1s and 2s, 4s, and 8s. So the binary equivalent from 0 to 15, 6, okay, is from 0, 0, 0 to 1, 1, 1, 1. Let me explain this a little better here. Okay, so 4 bits. Every combination of 4 bits from 4 zeros to 4 ones is represented here. How many possibilities is that total? Well, the total number of unique combinations of zeros and ones using 4 digits is 16. That's why hex is perfect. We have 16 digits, 0 through F. So any 4 bits can be represented by a single hexadecimal digit. So we don't have to write out all these 4 bits. We can just show it in a simple hexadecimal digit, a single hexadecimal digit. Okay, so I've mentioned that we can represent any 4 bits with 1 hexadecimal digit. What if we wanted to do 8 bits? It's very simple. If I wanted to represent 8 bits, let's say I have 8 bits. These are my 8 bits. I'll do these 8. So 0, 1, 1, 1, 1, 0, 1, 0. If those are my 8 bits, I can represent it very easily with 2 hexadecimal digits. Just divide it in half. Okay, that's a 7. And this is an A. It's that easy. So let me just randomly write out. There's another 8 bits. How would we represent that with 2 hexadecimal digits? Very simple. Find 1, 0, 1, 1. 1011, there we go, B. And find 1000. Where's 1000? Oh, there it is. 8. It's that simple. Okay. So in technology, in networking, computer science, whatever the case might be, it's a lot. You might sometimes see things represented in all these hexadecimal digits. Well, what they're showing you is just the actual binary digits. And it's very nice because we can just, whatever we're looking at, we see 7A, they're just showing us these 8 bits. Or if we see B8, they're showing us those 8 binary digits. Right. Hope that helps you understand a little bit about hexadecimal number systems.